All right. Hopefully you can see the slideshow. So we're on the digestive system. All right, we went over this already. I think we're all the way to the stomach, right? So we talked about swallowing, talked about the cardiac sphincter, which is called lower esophageal here. This might be, I don't know if that's a new slide, but anyway, that's we were on the stomach, so that is the function of the stomach. And so I believe this is like new. So you turn the bolus is the thing that we eat, like the chewed up food. And then once in the stomach, we turn it into chyme. And so the question is here is like, what's the function of the stomach? That's pretty much the function, to turn the bolus into chyme. How is it able to do that? Did you guys get vaccinated yet? You did? Did you? You did?
Yeah, that's what Johnson.
So functions that turn the bolus into chyme, like liquefy it. And so how does the stomach able to accomplish that? It has a third layer of smooth muscle. So in most of your GI tract, you have a longitudinal layer, a circular layer. Here in the stomach, there's a third layer, the oblique or diagonal layer. So there's a third layer of muscle to really push that food around, and then there's hydrochloric acid. Are you guys okay with me and the mouse? Okay. I just want to make sure. I'll definitely put it on. I'm anti-mask. I think it's just a lot of us have started to become vaccinated now, so we're. So, those are the functions of the stomach. And we talked about the regions. So the cardia region, the cardiac sphincter is here, and then there's a pyloric sphincter. And I was telling you that the function of the pyloric sphincter is to slow the movement of food into the duodenum. This is the small intestine. So you want to slow the passage of food across here. So that's kind of, we already talked about that. And then we talked about the different types of cells. I think that was on the next slide. The mucus cells. So the first two I was putting together, they're both mucus cells that secrete mucus. And then the parietal cells are going to secrete the acid, hydrochloric acid. And then we have the first enzyme that we're discussing here, which is pepsin. Here it's in an inactive form. So you see chief cells. So I'm down here now. Chief cells secrete pepsinogen. So that's going to be inactive, and when it hits the acid, that's going to activate it into pepsin. And then the last cell was the G cells that make gastrin. We'll talk about gastrin in a later slide. But essentially, it's gonna open your pyloric valve and let stuff move out of your stomach. So you see, here's the esophagus, moves into your stomach, the bolus becomes chyme, then it's gonna go out of your stomach and into this is the first part of the small intestine, called the duodenum or duodenum, and the main function of the small intestine is to absorb stuff, absorption. Before we get into that, let's look at these accessory organs. Let me just look at the next slide here. Yeah, okay. So we got 3 accessory organs here. I'm gonna go back to this slide. Let me just point them out to you. So the stomach's been taken out, but the stomach's right about here where my cursor is. It's kind of over the pancreas. Actually, it's more about right here. And so here's the beginning of the small intestine. So they've taken out the stomach, right? And so here you see the liver, you see the gallbladder in green, and you see the pancreas. And what you'll notice is that if you follow the liver, you see these ducts running down. So we follow this one, and it's running into the small intestine. And then you see this gallbladder, same thing. Cystic duct, back into the common bile duct, into the small intestine, into the duodenum. And same thing with the pancreas. You follow these 2 ducts, the accessory duct, the pancreatic duct, they are both emptying into this beginning part of the small intestine. So you've got 3 things: liver, gallbladder, pancreas. They are all secreting things that are going to go into the small intestine. So they're not part of the small intestine, they're not part of the GI tract, but they're helping with digestion because they're all secreting things that help with digestion. And so there we go. So the liver does many things, but here with the digestive system, it's going to make bile. Bile is going to take the large drops of fat and make them smaller so that the enzyme is called lipase, so that the enzyme can get to it. So the liver is always making bile. You're not always eating fats. So when you're not, when you don't need it, it gets stored in the gallbladder. So sometimes people get their gallbladder removed, they'll be fine. They just gotta watch their fats, how much they eat, but you can still live because your liver is still making bile. All your gallbladder does is just hold it. So this duct can get kind of clogged up. You get a stone, whatever it is. You get something clogged up in here, or it could be here, and then you just kind of make a cut right here, pull this thing out. But you can see all the ducts here, and they're all leading into here. And then here, notice, okay, so this right here where this box is, here it is over here, right? So this duct here is coming from the pancreas, and then this is the common bile duct coming from the liver and gallbladder. There's muscle right here, and there's muscle right here. So you notice, if you can see it, it says there's a sphincter So a sphincter we know is a ring of muscles, and then we have this word hepatopancreatic ampulla. Big words are easier words. Hepato meaning liver, pancreas meaning pancreas, pancreatic pancreas. Hepato, whenever you see the word hepato, like hepatitis, that's an inflamed liver. And ampulla is like another type word for like a sphincter. But anyway, it can close off. So you can, the body can close this off. So that's coming in a later slide. I was just showing it to you. But right now, we're just on this. Liver, gallbladder, and pancreas. So let's talk about what the pancreas does. We talked about the pancreas in the very first chapter because it has an endocrine function. If you remember, it makes some kind of hormones. I know you remember too. You remember insulin, and then some of you remember glucagon, and hopefully you remembered GHIH or somatostatin and the pancreatic polypeptide. That's an endocrine function. This is an exocrine function, meaning that it's going through a duct. This is not like a hormone. These are enzymes. So there's a lot of digestive enzymes that the pancreas is going to release and put into the small intestine. And I have a list of them on another slide. And it's long. So besides the enzymes, it produces bicarbonate. So bicarbonate, we consider bicarbonate an electrolyte, but for now, bicarbonate, think of it as an antacid, something that's going to raise pH. So when you make pH higher, you're making it less acidic. Lowering pH makes something acidic. So if we go back to, there's part of your list. I don't want to open the present before it's the birthday. If we go back to here, is there a better one? No, we'll go here. All right, the stomach's missing, but here it is. And from the stomach going into the small intestine, you have acid. pH of like 1.8 or 2, pH of around 2, let's say. And then here, coming from the pancreas, is bicarbonate with a pH of 8, 8.4, something like that. We'll say 8. So pancreas has a pH of 8. Stomach acid has a pH of 2. So when they meet each other, we'll average the numbers out, right? Let's say it's an average of 5, right? So 8 and 2 meet, and it becomes 5. And you're like, oh, that only raised it from 2 to 5. And in fact, 5 is still an acid, right? Because 5 is below the number 7. So if it's under 7, we call it an acid. But it's not like that really, because every time you go from like 2 to 3 or 3 to 4, it's times 10. So when you go from 2 to 3, that's 10 times less acidic. Then when you go from 3 to 4, that's 100 times less acidic. And when you go from 4 to 5, that's 1,000 times less acidic. So let's say that they meet in the middle and it only goes to a pH of 5. That's 1,000 times less acidic. So it makes a big difference. And in reality, it raises the pH even more than that. But it makes a big difference. Just moving one number on the pH scale makes a big difference. So without that acid, without that bicarbonate from the pancreas, the acid is eventually going to make it's going to ulcerate your duodenum. So the small intestine has, let's not get to that yet. Let's stick with the enzymes. So here are the enzymes. I've written 6 of them here, 6 out of the 10. And I've written the substrates. So a substrate means the thing that the enzyme works on. I didn't write all of the enzymes here, I just wrote some. But that first one up on top, amylase, your saliva makes amylase as well. So amylase and lipase is made in different regions in your body. So I just left it here for the pancreas. So amylase breaks down starch, which is called amylose, but it's fine. Amylase breaks down starch. Lipase breaks down lipids. And then the other four that you see there are proteins. They all work on proteins. Trypsin, chymotrypsin. So you gotta, chymotrypsin is like the word chyme before the word trypsin. So you gotta learn the word trypsin and then chyme before it. Chymotrypsin. And then there's aminopeptidase. Elastase. Elastase, if you look at the spelling of it, it ends with ASE, therefore we know it's an enzyme. And it looks like elastic. So it's breaking down elastic fibers. Aminopeptidase, ASE enzyme, peptide. When I see the word peptide in something, that tells me it's a protein. So it's an enzyme that breaks down proteins. Now, it goes after the amino and the protein. You notice here that out of this list, 4 enzymes, 4 out of the 6 are helical proteins. And we can add a 7th enzyme in here from the stomach. That one's pepsin. And the substrate of pepsin is protein. So I'm giving you a total of 7 enzymes. And they all work on proteins. So that tells you something wrong with my mic. So can you guys hear me at all?
I couldn't unmute myself. It sounds like, I don't know, like airplane noise or something.
It sounds
when you go to talk sometimes. It's like going in and out.
Is it, okay, let me ask you this. Is there a difference between like the way I'm talking to you now and like the way I'm talking to you now? Or is it still the same?
It's different from when you were presenting. It's normal now.
Maybe I'll move.
Because I listened to the recorded lecture, and you can hear that noise really bad.
Is it the noise from me rocking the chair, or is it the noise
It's
from
the like air.
the air conditioning?
It sounds like an airplane. I don't know, like you're about to take off on the. It's really loud. It's fine now.
All right, I'm gonna try to just take. I mean, I don't know. It might be the air conditioner. And
That's what.
yeah, and I wish I could do something. They'll only listen to you guys. So you guys, I mean, I can't ask them to keep the air conditioner off. I wish I could. I'll move around though.
Okay, thanks.
Maybe that'll help. I don't know.
Yeah, because once you go back and listen to it, you can't hear it too good.
Yeah, that's not good.
That's why I'm here. Trying to get most of it. Once I listen to it, I can't.
Yeah, I'll try to stand under it or something. So, yeah, so the reason that okay, so you see 5, we have a 5 out of 7 enzymes that deal with proteins. So proteins are very satiating. If you're looking for something that makes you feel full, and you're not going to be hungry as fast, you always go for a protein. Proteins make you feel the most satiated. Lipids make you feel the least satiated, like the least full. Right, so that's just like FYI. But your body spends a lot of energy and effort breaking down proteins. So to this list that you see here, you should add pepsin. So I'd like you to know where these enzymes are made and what the substrate is. So these enzymes on this list in front of you, they're all made in the pancreas. pepsin made in the stomach. The substrate for pepsin is proteins. I've got 3 more enzymes. I saw them on the next slide. So let me just, I'll go to the next slide and you can get all 10.
The rest are made in the pancreas, you say?
All of these here are pancreas. So 6 from the pancreas, 1 from the stomach, and it's going to be 3 from your small intestine. There's the 3. Well, actually, I've got pepsin up there. That was the 7th one, pepsin from your stomach. And I have a typo up there. Protein, what I'm saying is pepsin is produced by the stomach, breaks down proteins. So look at that second bullet point. So we're going to talk about we will discuss the brush border in a minute. The brush border is just part of your small intestine. So you could just say small intestine. But I've seen them like on tests where they've talked about the brush border as an answer. So just keep that in your head. The brush border is like I'll show you what it is in a second. I've got a slide of it. But anyway, maltase, sucrase, lactase, those are all disaccharides. Or if you don't want to learn the word disaccharide, just replace the A with an O. Maltose, sucrose, lactose. Because that's what they work on. See, if it ends with OSE, it's a sugar. If it ends with ASE, it's an enzyme. So you've heard of lactose before. You've heard of malt. You've heard of malt. So maltose. And you may or may not have heard of sucrose. Sucrose is regular table sugar. So the enzyme that breaks those down are just put an A there. So that should make 10. I just stopped it at 10. Those are 10 enzymes. I'm saying on the last bullet point, you don't have to remember that because I'll just get you confused. But we've already discussed it. You have amylase and lipase in your saliva. Lipase doesn't really, you have lipase technically in your saliva and in your stomach. It doesn't really do a good job. It's really the pancreatic lipase that is breaking down fats. And that's what Ally does. The weight loss drug Ally, it blocks lipase from your pancreas. So if you block lipase from your pancreas, that means that lipase is not going to get broken down. And if you don't break down lipase, then your intestine can't absorb it. Your small intestine will not absorb it if it's not broken down. So if you're not going to absorb it, that's it. It's not calories. It's just going to keep moving through you, and you're going to get rid of it. Of course, when you don't break down something, a nutrient in your body, you're going to kind of feel it. So it's not like we can eat a lot of fat and then not break it down, because it moves a different way in our intestine. Anything that's like, anytime you have malabsorption, you're going to feel it. So hopefully that's, you've got 6 here, pepsin 7, 8, 9, 10.
What were the last 2 made in?
Lipase and amylase?
Yeah.
Oh, those are made in your pancreas.
Pancreas too.
Yeah. The main place is your pancreas, but it is also made in by your saliva. Here's your small intestine. There's 3 parts to it. The other 2 names, if you could just kind of be able to recognize it, the jejunum and ileum, if you just recognize it, that would be good because it's used in other words in the future. But for now, the duodenum is really the only one you really need to know for now. Because that's where most of the action happens. But you will see words like something like the word jejunal or ileal. Like you'll see those words in other words, like after you get out of this class. So actually, we're seeing both here. We're seeing the small intestine and the large intestine. So here's the stomach, pyloric sphincter right here. There's the beginning of the small intestine, the duodenum. I don't know, at some point we get to the jejunum, wherever it is, and then the ileum is at the end. And then right here, where my cursor is, that's the end of the small intestine and the beginning of the large intestine. Right there where you see the appendix, that's kind of the beginning of the large intestine. So there's 3 parts to the small intestine. I'm actually gonna go to the next slide. All right. So what does the small intestine do? It absorbs nutrients. That's the main thing. This is where, so for example, you eat a slice of bread. The slice of bread, what is bread? It's starch. Starch is going to be broken down by amylase. And when you break starch down with amylase, it gets turned into maltose. And then maltose is going to be broken down by maltase, and that gets turned into glucose. So where does the glucose from that bread go? It goes into your blood. So this is where that happens. This is where the glucose enters your bloodstream. This is where your blood sugar goes into your blood. And other things, proteins, amino acids, this is where it all enters your blood. So there's obviously chemical digestion that happens in the small intestine because there's enzymes breaking down food. If you just drink a liquid diet, so you drink like Ensure or I don't know, whatever those drinks are, SlimFast, right? It's all liquid, right? So mechanically, physically, it's already broken down, it's already liquid. But the molecules, even though it's liquid, the molecules are still too large. The fat is too big. The drops of fat are too big inside there. The proteins that are in SlimFast, they're too large to get into your blood. It's liquid, so it's small, but they're still too big. So you got to break them down further. So that happens in the small intestine. But I didn't really talk about that. I talked about the absorption part. So I'm going to go back to this slide in 1 second. So the inside of your intestine look kind of like this. So these circular folds force the chyme, as I'm writing here, to go in a circular pattern because if you think about the water flowing in a ditch and it flows through a pipe in a ditch, right? The top part of that pipe, culvert, whatever, the top part of it is going to stay dry. The bottom part of it is going to have like water flowing through it, right? But the top part never gets any of it. So we don't want that type of thing to happen in your intestine. We want all of that pipe to get, we want all of the space in there to get chyme. So we're going to make that stuff go. So you can't really see it, but these folds are forcing it's forcing all of the chyme to go in a circular motion. So that each part of that intestine gets exposed to the chyme. Because you want to absorb stuff out of it, right? It's less efficient if you just have it down here and not at the top. Thought I had a better picture of it. When you look in the intestine, there are these finger-like projections that we call villi. The stomach, it makes pits. The intestine, they make villi. And so up there you see, well, there's one villi, and you see these cells around it. So you got this villi, and you've got these cuboidal cells. In the stomach, it dropped down, but here it goes up, and then you see the bloodstream here. So this is a villus, or villi for plural, and so this is like the lumen in here, and so here's your piece of maltose. It gets turned into glucose, and it'll just come over here, and it's going to squeeze. Well, it'll do a couple of things. It'll go into a certain cell, or it might just squeeze through. Where's my cursor? Squeezes in between and enters the bloodstream. Look, here's a lacteal. So what is that going to transport? A lacteal is part of what system? Actually, if you follow the green down, you can see it tells you part of your lymphatic system. So what does your lymphatic system transport? You're thinking immunity, but yes, but what else? I hope you're saying lipids. So the lipids are going to enter the lacteal, the carbs and the proteins are going to enter the blood, right? 3 types of energy that you get from food: carbs, lipids, proteins. Carbs and proteins go into the blood. Lipids, for the most part, go into the lymphatic system. But nevertheless, this is where all the stuff, and of course vitamins and minerals, they're going to enter here as well. So you have a bunch of these figure-like projections, and they, as you see here, they increase the surface area. The more surface area, the better. Because this small intestine is for absorption. And then if you look at the villi, it's hard to see, but like look at these cells, like look at this cell, right? They've got little villi on top of them. So these cells, if you look at it here, like here you can see the villi, right? But if you look here under a microscope, really even a high power microscope, it looks like a brush. That's why I'm calling it brush border. You can't make out the microvilli, it just looks like a brush. So that's what's making the enzymes. You could say they come from the small intestine, and because they do. It's just like if you wanted to be more specific, you could say microvilli. But anyway, the microvilli increase the surface area even more. So I've got villi increase the surface area, microvilli also increase the surface area, and the circular folds make all that chyme go in a circular pattern. Anybody got any questions?
Did you say the villi is the brush border?
The microvilli.
Okay. You don't have to worry about the cells. It's okay. Some of them absorb. Done. I mean, you know mucus is going to be secreted. It's the GI tract.
Not mucus like the stomach, right? I mean, the stomach produces a lot, but the rest of your GI tract produces some mucus. Can't have this all dry out. Here's your large intestine. So here's the ileum, in other words, the end of your small intestine, right? So most of the absorptions happened. Not that we don't have any digestion in the large intestine, but that's not its primary job. The primary job is to get water back, reclaim water. The large intestine will reclaim or recapture about 80 to 90% of the fluid of your chyme. So chyme gets turned into feces. These are more anatomical structures, but you have the cecum here. You can't really see it, but it's like you'll see it like if you ever look at a cadaver or something, it's just a pouch. And then here's your appendix, right? So, I mean, appendicitis, itis just means inflamed. Of course, you don't want this thing to break because at this point, it's all liquid. So you don't want liquid poo just filling up your cavity here. You know, we think that the abdominal cavity is completely filled with stuff. There's space in there. Like when that appendix breaks and all that liquid poo flows into your abdominal area, they take like a turkey baster, not literally a turkey baster, but it's kind of, just start sucking it out. But they've got one that, they've got ones with motors and stuff, but that's all, it's not very complicated. And they gotta sew that thing back up and hope that that stuff doesn't infect your blood. So hopefully you catch it. And you can see it's on your lower right side. So you'll learn that where you have pain kind of means something. I don't know if we have so if pain is, so usually when like somebody has like pain in their stomach, you can make them like point to it. Like just tell them to take one finger and just point, right? And so if it's in the upper part of your abdominal area and it's over on the right side, maybe it's something with the gallbladder, right? And people with the gallbladder, they're going to feel something in their shoulder blade too. So we call that referral pain, right? Pain's not always pain. Pain that happens in one area might mean that the problem's in another area. It's weird like that. Like sometimes your elbow will have the pain, but the real thing is in your shoulder. That's because of something with they're called dermatomes. They're just, but anyway. So on the right side, maybe gallbladder. In the middle of your, upper middle of your abdomen, maybe pancreas. So it's not uncommon that the pancreas that you get acute pancreatitis. It just inflames for a while, right? And then on the left side, they're not showing it to you here, but that's where your spleen is. And then down here, here's where your appendix is. So lower right side pain, maybe is the appendix. I want to say that maybe with all these things, right? And then there's other things, right? It kind of gives you some control, a little bit of control. You can kind of try to figure out where it is. If you're having pain, like above your belly button, down by like up towards your sternum, I mean that's not going to be. It's not going to be appendicitis. It's probably your pancreas. Lay off the alcohol for a few days. Anyway, where are we? We're at the end here. Yeah, the large intestine. You know, the food goes up, ascends, it transverses, it descends. I'm not really caring about that on the test because that's kind of anatomy. This is called sigmoid right here. It's like a half of a sigma, like that letter in math. Anyway. That's it, it goes out. You have some sphincters here. You've got like 2 more. I don't really care that you know it. This one, I'd like you to know. It's already labeled here. Ileocecal, named after the ilium and the cecum. So ileocecal. So you have cardiac sphincter that kind of forms a boundary between the esophagus and the stomach. That's the cardiac sphincter. That's between the stomach and the esophagus. And then the one between the stomach and the small intestine we call pyloric. And then between the small intestine and large intestine, ileocecal. You can call it sphincter or you can call it valve. I like the word valve better. It sounds less, I don't know. It's just one of those words that bug me. Oh, they're showing you the 2 sphincters on this side. Anyway, but last thing about the digestive system is, yes, the phases of digestion. So digestion, a lot of the control of digestion is coming from your brain and chemicals. Just like control of heart rate, control of blood pressure, control of respiratory rate, your brain's making stuff happen. I'm gonna get off of this slide. Actually, I don't even know why I'm on it now. Okay, so there's 3 phases to digestion, and the first is the cephalic phase, and cephalic meaning brain. So something to do with your brain. We've actually talked about this one already. We were talking about Cinnabon, and I forgot the cookie place already. We spent a lot of time, what was it?
American.
The what cookies?
American.
America?
I don't remember.
Wasn't it named after some lady? Like Aunt somebody? I don't want America cookies.
Yeah, that's what the American. Yeah.
That sucks as a name. I want Aunt somebody's cookies. Isn't it like Aunt somebody? Aunt Betsy? I wouldn't want cookies from Aunt Betsy.
And present. But then the
You don't want your cookies from an aunt? I want cookies from America. Sounds like shitty cookies. Grandma something cookies. That's what I want. Grandma May's. Oh, whatever. I'm gonna open something in the wall. Everybody's making money in the mall. I need to go open me a cheap sunglass and phone case kiosk in the mall. People hanging around there paying $15 for a stupid phone case that they got for like $1.50. That's what we need to open. Cephalic phase. You smell the cookie, it is going through your olfactory nerves into your brain, and the brain stem is activating the nerves in your face, which is hooked up to salivary glands, and you could just use the numbers here. Your 7th cranial nerve, your 9th cranial nerve, and if you don't even remember the cranial nerves, just say that they're activating salivary glands, because that's the point. It's making you salivate. I mean, that's really, smell the cookies, salivate, be hungry. That's the cephalic phase. Cranial nerve 10, you already know that because that's the only one, I keep saying it over and over. The vagus nerve is the only one that's going down past your shoulders. So the gastric glands, gastric means stomach. So we're going down to the stomach. That's got to be the vagus nerve. And it's stimulating your gastric glands. It's also making your, I didn't put it here, but it's making your stomach muscles contract as well. But it's getting ready. It wants cookies. It's getting all the juices going. Because Aunt May's cookies, not America's cookies. It's stupid. And you know what? You look at their cookies, it's just like shitty cookies. It's like the stuff you get at the store that comes in those like frozen packs, and all you do is just like put them out on the, and they just make it big. It's not good. It's not like a delicious cookie. It's not the Cinnabon of cookies. So therefore, they just make it big. Well, it tastes like shit, but it's really big. So it's like all of our food outside of New Orleans. It sucks, but 33% more of it. Bloomin' onions. There's a lot of them. They're a horrible bloomin'. I don't know what I'm talking about food now. All right. Have you guys ever went to, like, I don't know, I hate those places. I know, so I'm not knocking any of you guys if you like TGI Fridays or Outback Steakhouse. I mean, it's okay, I go sometimes, but I'm just not into bloomin' onions. You just took a bunch of onions and like fried it. You didn't even do a good job frying it, it's still got all the oil on it. I don't know how those places are surviving in New Orleans. We're just taking like bread and we'll just put a bunch of cheese on it, melt a bunch of cheese on it. That's it. And then people are like, oh, I love the cheesy bread at Red Lobster. Who goes to Red Lobster anymore? I'm not knocking you guys. I know about the cheesy bread because I eat the cheesy bread. And it is good, but it's just, I don't know.
Red Lobster is like when you have no other seafood. That's when you Red Lobster.
I like driving down the street and I see a bunch of dudes with these 55-gallon drums that they converted into like a barbecue. They've got like 4 of them just on the sidewalk and they're just selling stuff out of like styrofoam plates. It's like, and like getting smoked turkey necks from those people, I mean, it ruined every other restaurant for me, to be honest. That's what New Orleans did. I can't walk into TGI Fridays. I just can't. I had those dudes smoke turkey necks. I can't eat other stuff. I can't travel anywhere. It's ridiculous. And my wife, she's raised here and she does the same thing. She's like, oh, I thought that food would be a lot better than that. I was a little disappointed. Really? You're in Duluth. What did you expect you were going to eat here? There is no other place. There's New Orleans, and there's maybe San Francisco, and maybe New York, and everything else is Cleveland, as the saying goes. What kind of culinary experience did you expect to have in Kansas City? If we went to Hawaii and she was like, oh, the food is just like, yeah, it's, I think people take it for granted what real nice food that exists here and not other places. Oh, did I even talk about any of this? All right, that's the cephalic phase, right? It's all about you thinking about it. Gastric phase. Now that you've eaten the food and the food goes into the stomach. So what's gonna happen, in the stomach you have receptors. Chemo and strep receptors. Chemoreceptors are measuring chemicals. They're measuring the pH. So when the food gets into your stomach, the pH starts to go up, right? It becomes less acidic because the food's buffering the acid. So that's going to hit the receptors. The fact that your stomach gets stretched out, that's going to hit receptors. And then the food going in your stomach, like makes it less acidic, that's going to trigger receptors too. pH goes up to like 3, well, that's too high. So what's going to happen is that there's going to be a signal sent up to the brain, and then the brain sends a signal back down to your stomach muscle. This is the second bullet point here. So your brain sends a signal back down to your stomach and makes your stomach muscles start moving, peristalsis. That's what I'm writing with the second bullet point.
So that's just breaking it down instead of putting all of this stuff.
Yeah.
Okay.
Yeah, I mean, as long as you know what's going on, like the receptors get triggered because of the food, and then the brain, those receptors are going to send a signal up to your brain, and then your brain sends a signal back down to your stomach muscle to make it start going. That's good enough. That's what's happening. I just wrote it different. ENS is enteric nervous system. That's from early in the lecture. And then look at bullet point number 3, gastrin. Stimulates the production of gastric juice. Okay, so we'll want to make more stomach juice, because that's got acid in it and stuff. Relaxes the pyloric sphincter. That means you're emptying stuff out of your stomach. Coffee makes your body release gastrin. If you're wondering why coffee makes you like that. And it makes us, the gastric phase is like your stomach is moving around a lot more, breaking down the food and trying to get rid of it and send it into the intestine. So increases motility means you're moving it along. We want to get it into the intestine. And it's negative feedback. So once your pH gets back to a normal level, once it's not stretched out anymore, the gastric phase is going to stop. So that's the second phase of digestion. The third phase, now the food goes into the intestine. So now we got to talk about the intestinal phase. And again, that first, I know this one's big.
Oh my God. You're not putting this on the test, are you?
Yeah, it's on the test.
Oh, you are overloading us.
This describes we still got like a week. We just think about what's happening. I know I wrote a lot of words here, but what's happening? Your intestines are getting stretched out.
Our intestines are getting stretched out.
Yeah, when food goes into the intestines, there's receptors that are getting triggered. And then what's going to happen? What happens? The pH actually changes too, because it becomes a little more acidic, because that acid con is going into your intestine. So you're triggering receptors. But mostly stretch receptors, right? So the stretch receptors are sending a message up to the brain. This is the same thing. There's stretch receptors in the stomach that send signals up to the brain, and there's stretch receptors in the intestine. Just what do they do is different. With the stomach, you want parasympathetic stimulation. Remember, parasympathetic just means rest and digest. So that when you have parasympathetic stimulation, you're digesting your food. The intestinal phase is trying to inhibit this They don't want the stomach giving it more food. So it's trying to slow it down. So I put there decrease gastric empty. The gastric phase is going to cause gastric empty. The intestinal phase is going to try to decrease gastric empty. It's like a competition between the intestine and the stomach. The intestine is telling the brain, hey, I've got liquid cookie in me. I'm trying to deal with this. The stomach's like, this dude keeps eating cookies, so I need to get rid of what I have because I keep getting new arrivals. And so they're arguing, they're both arguing with the brain. So we got two hormones here. CCK, cholecystokinin, and secretin. So let's deal with CCK first. CCK is going to cause the pancreas to secrete its enzymes. Well, actually, the real thing that it's going to cause the pancreas to release its enzymes, and it wants the gallbladder to contract, to send bile down. So it's asking for help. The small intestine is telling the brain, hey, ask the pancreas and the gallbladder to help me out here. I've got all this liquid cookie in me, and you got it with a bunch of frosting. Not the buttercream stuff. Well, buttercream's like the real frosting, right?
Yeah.
With buttercream, not whatever that crap that they try to pass off as frosting. What is it? That's all it is? I don't like it. It just doesn't, it's like a disappointment. I feel so disappointed. It's like the favorite part of the cake. No, you're gonna get the calories from the cake anyway. It's just give it to you, let me enjoy it. So CCK is gonna cause the pancreas and the gallbladder, the pancreas secretions, pancreatic juice, and the gallbladder contraction. Secretin is doing the same thing, just kind of for a different reason. So if you see there's a difference in what activates these. CCK is getting activated by amino acids and fatty acids. So we're talking about the energy from the food. That's what's activating it. Secretin is getting activated by the pH. So it's trying to raise the pH. It just got this gastric juice from the stomach that had a low pH. And so it is trying to stimulate the pancreas because it wants the bicarbonate. So both of them are secreting the pancreas. They're stimulating. CCK and secretin both stimulate the pancreas. And CCK, the word cholecysto means pancreas. Cholecysto means gallbladder. Like I think they call it a cholecystectomy or something like that. You get your gallbladder taken out. So anyway,
So the secretin is activating the pH, you said?
it's activated by the low pH. As soon as that stomach juice goes into your intestine, it makes it more acidic. So that triggers the receptors. secretin is going to want to slow down that gastric emptying. It's going to want the pancreas to release bicarbonate.
Also wants to slow down.
That is my last slide on the digestive system. Let me work backwards and talk about things that I want you to know about. There's not as many as you think. This is one of them, unfortunately. And it's not like you need every word that I have or every word. It's just if you can kind of understand and write about what's going on. And you don't have to use all the words. Like, do you have to say, like, look at the first one, right? Do you have to say medulla oblongata and inhibit parasympathetic stimulation? You don't have to say all that. That's like too much to remember. But if you could just describe in your own words what's going on, that would be good. So there's stretch receptors, and they're sending those signals up to the brain, and they want the brain to prevent gastric emptying, prevent the stomach from giving it more stuff. This is the small intestine trying to say, let me work with this food that I just got. Tell the stomach to slow down. I've got the job to absorb. It's not easy absorbing stuff. So whatever you can think about in your own words is fine. CCK and secretin, you should know what those two hormones do. They both of them are going to cause more pancreatic juice to come. They're going to stimulate the pancreas to secrete their juices. CCK also makes the gallbladder contract. So, yeah, this has 3 phases, so this is 1. So phallic phase is pretty easy. I mean, if you don't know the nerves, you know, that's okay. I'd like you to know the 10th cranial nerve, but, I mean, you should have learned all these nerves last semester, all 12 of them, but, yeah. What does the word glosso mean? What about pharyngeal? It's up in your face somewhere. Pharyngeal pharynx, right, your mouth. Glosso tongue. So it's like tongue, mouth, something going on with your tongue and your mouth. Right. So obviously there's all these salivary glands over there. You've got like one under your tongue and some on the side of your tongue. And so that's that's one of the cranial nerves coming down. And then your facial nerves all just up in here. Right? It makes a lot of stuff go. All right, so anyway, one question will be about the phases of digestion. So, phases of digestion. I think I got a total of 4 questions I'm gonna ask you. Phases of digestion. That's a long one.
Against all the other hormones.
Well, this one's not that long.
Okay.
What-
The other 33 or
What's
whatever we have to
What's the,
figure out.
oh, yeah, you're right. I mean,
Yeah.
there's a lot of questions.
Take us through World War III here.
What's the function of the small intestine and how is it adapted to perform that function? What I'm saying is this slide in front of you. Like, what does the small intestine do? And what's so special about it that it can do that job? Well, it has villi and microvilli, and those are both gonna increase the surface area, and the
Function of the small intestine and what?
how's it, like, what's the function of the small intestine, and how is the, I don't remember how I said it. What's the function of the small intestine, and how is it adapted to perform that function? Meaning, like, what features does it have, like those 3 features? What features does it have that let it do that? I can ask the same question about the stomach. So one question could be about the small intestine. One question can be about the stomach. So this is the small intestine one, and
Professor Claus, could you tell us what earlier you were talking about the pH is 8 and something's 2, and when they get together it comes out to be 5. What were you talking about there?
oh yeah, no, I was just saying, I was kind of just talking out of my ass there, but the pH of your stomach juice is about 2. On a scale of 1 to 14, the pH of your stomach's like 2. And then I was saying that the pH of the bicarbonate that comes from your pancreas is like 8. I don't know if they meet together to make it 5, I was just talking. But the point is, the stuff that comes from your pancreas, there's sodium bicarbonate, it's baking soda. Like, you can use regular baking soda as an antacid, right? And so your body makes baking soda, and it comes down this tube, and it meets the acid coming from the stomach. So it's just acid and acid. I don't really care about the numbers. So stomach, function of the stomach, how is the stomach adapted to perform that function? You want to liquefy your food, that's what the stomach does. So this is question number 3. Question number 4 is your enzymes. I'm not going to do all 10, I'll pick some. So I might say, list the enzymes that deal with proteins and say where they're made. So if I were to do that, if I were to choose proteins, you would list a total of 5. Those 4, and then you have to add 1 to it. Which one are we going to add to it? Pepsin. And
Pepsin.
Pepsin's not made in the pancreas, is it? Enzymes, all these enzymes that you see in front of you, they couldn't handle the pH of the stomach. That'll mess these enzymes up. It'll denature them. That's why they're all made after the stomach, because it's too acidic. Pepsin is like a special enzyme that can handle, it's designed to handle low pH. In fact, pepsin will not work in the large intestine, the small intestine, pepsin won't work, because it's not acidic enough. Or I could say which enzymes, list the enzymes that deal with carbohydrates. So which one of these on this list is carbohydrate? Obviously, it's not proteins, so yeah, that starches are carbohydrate. These are carbohydrates. Maltase, lactase, and sucrase. Those are carbohydrates. Starches and sugars are carbohydrates. So I could ask it that way. I won't ask you to put all 10, I'll pick probably one or the other.
Just give us a definite on those four, because you're already telling us out of 33 questions, 10.
Yeah,
Try
but
to
those are
persuade-
questions that you've had.
I know.
They're
but
all old questions.
They, but it's still trying to study,
A week
or,
from today.
that's a lot,
Monday or Tuesday of next week.
that's a lot.
I imagine you guys are gonna come on Tuesday.
Gotta have some definite questions, like we can get.
Well, those four are probably definite.
Okay.
Okay, so here's what I'm gonna do, I'm gonna have 10 questions from those other stuff, right? And then I need 5 more questions. I'm probably gonna pick 3 of these 4. And then I'll probably do 2 from urinary.
So
And
the
you're gonna
next
know
one
what
we're
those
going
are.
into.
Huh?
So we're going into another chapter on Wednesday?
Not super long, but,
Okay.
because I can't
Have to have time to study.
explain the whole chapter.
You've been studying.
You've been studying all semester. You have, I know you have.
Oh, but still trying to keep all of that stuff
That's a lot of stuff.
It is a lot of stuff.
to retain. So it like goes in, once you got it, then it slips away. if you-
Imagine having this like all day.
I know.
Have this till 11, take a lunch,
So-
go back.
But
Do it again in the
so
afternoon.
long, so it's like program, you got that in long term anyway. This-
That's like nursing school, they just do this all day, not on this topic, but it's just information all day.
All day long.
You're just writing stuff down.
For nursing.
But you'll get used to it, people get used to it. First semester, they suffer, and then they get used to it. And everything starts coming together. All right, let me stop this here. I was gonna go into urinary, but I'm not. I tell you guys don't want me to.